And hi, everyone. While we do get ready, I just want to say that this is John DeWitt, one of the co-hosts today. We're going to get started in just a few minutes, but if you haven't already taken a look at the current slide, please do. There are a few links that will be important for today. There are a few tabs that you may want to open up in your browser for today's presentation. Also, if you're planning to run R locally, please make sure you have a Census API key. The URL is on the current slide. After obtaining the key, you must then activate the key following the instructions that the Census Bureau will email to you. We'll get this started in just another minute or two, but please feel free to open up some of those links in your tabs right now.
So are we ready to start, do you think, folks?
Sure. Bill, we can go ahead and get started.
Okay. Well, welcome everyone who's joined us for the very first of 3 sessions on our analysis of the census, the 2020 census, and the 2016 to 2020 American Community Survey data using R. There are 3 of these 3-hour sessions. We have this one today, and then we have 2 more on subsequent Fridays, the 18th and the 25th, all with Professor Kyle Walker, who is at Texas Christian University and director of their Urban Studies program and a geography professor. But more importantly for us, is a real expert, the expert on accessing census data and American Community Survey data with R, with programs of Tidycensus. These programs, all 3 of these webinars are webinars that are available to people who are just starting. You don't have to be an expert on R. You don't have to be an expert on his programs. He will talk to you and teach you from the beginning to the end. And what's really important this year is we're going to have current information on the 2020 census. And in the last session on the 25th of March, probably the first ability to analyze the 2016 to 2020 American Community Survey, because those data are just coming out a few days before. So we hope you'll stay with us for all of these webinars. And, you know, I think this is just an exciting opportunity for us with the Social Science Data Analysis Network. This is a program at the Population Studies Center in the Institute for Social Research at the University of Michigan. What we do is try to make census data accessible to teachers so they can use it in their classes, so that there can be census data analysis in all kinds of undergraduate classes. And we try to make it easy for teachers to do that. And these particular webinars are going to deal with how you can use R to be able to make that happen. So without any further ado, I'm going to pass it over to John DeWitt, who will say a few more things, and then finally to Kyle Walker. Glad to have you with us.
Hi, everyone. I'm going to just highlight the fact that, as Bill mentioned, we will have 2 more sessions later this month featuring Kyle and highlighting other features of some of the R packages. So next week, just over a week from now, we will have Kyle talking more about spatial analysis, making maps of the 2020 census data in R. And later, as Bill said, we'll have kind of the first opportunity to look at the latest 2016 to 2020 ACS estimates that will be coming out next week. So we look forward to those sessions. Please check your emails. We will send you follow-ups later that will include opportunities to register if you have not already. And without further ado, I will turn things over to Kyle.
Excellent. Well, thank you so much, Bill and JP, for the introduction. And I'm going to go ahead and share my screen, and we'll go ahead and get started. All right. So welcome everyone. Thanks so much to the University of Michigan, to Bill and JP, and to SS Dan for hosting me again this year. I had a great time giving a series of workshops last year, and I've been very much looking forward to giving this updated series of workshops this month about using R and the Tidycensus R package to analyze census data. And the focus of this series of workshops is going to be working with the updated data. So typically, if you've been using Tidycensus before, you may have been working with 2010 census data or older American Community Survey data, but we have the opportunity now to take a look at some of the most recent data available, and in the case of the March 25th workshop, some data that still is yet to be released. And so today's workshop covers analyzing 2020 census data with R and Tidycensus. And just kind of to give you a little bit of background about me, without getting too much into the introduction. So I work as an associate professor of geography at TCU, and I'm also heavily involved as a researcher and consultant in the area of spatial data science and kind of spatial software development. Some of the R packages that I've developed include Tidycensus and the tidyverse R package, which tidyverse is actually my most popular package, which gives access to census shape files in R, which you'll be introduced to next week. And I've developed a few less popular packages that nonetheless I find quite useful, such as Mapbox API, which lets you use Mapbox web services in R. I've been working for the past 5 years and finally finished it late last year on my book, Analyzing US Census Data, Methods, Maps, and Models in R. That covers all of the content that we're talking about today and much, much more. It's free to read online, so please do check it out if you haven't already. It's set to be published sometime this fall in print. So we're kind of putting those final edits, final touches on it, and CRC Press will be publishing that this fall. So a little bit about the workshop series, just very briefly. Today is all about 2020 US Census data, specifically looking at the data tables. Next Friday, we'll continue the conversation on the 18th about 2020 census data, but it will be about spatial data and how you make maps in R and make maps of the 2020 census data. And then the final workshop on March 25th, we're going to get next Friday. In fact, no, next Thursday, actually. So a week from today, we're getting the new 5-year American Community Survey estimates. We'll have a first look at how to use those in R the following Friday. All right, so with that in mind, let's take a look at the agenda for today. The general structure, just with respect to how you might be planning your participation, is we're going to go sort of in 3 parts and then take a short break at the end of each part, where I'll have some exercises for you, and you'll get the opportunity to ask some questions. So the first hour, we're going to be focusing on getting started with 2020 census data in Tidycensus. And in the second hour, we're going to be focusing on wrangling those data and kind of exploring and analyzing the data with tidyverse tools. And in the final hour, we're going to focus on data visualization. So show you a few methods that you can use, focusing on the ggplot2 package for data visualization in R, or you can make everything from basic exploratory graphics to much more sophisticated and involved plots. So I think there'll be quite a variety of interesting nuggets. For those of you who are brand new and have never used Tidycensus before, and for those of you who might be more experienced and have used it for some time. All right, so let's go ahead and get started looking at 2020 census data in Tidycensus. And so I want to cover very briefly before we get started, and even before we dig in, how you can get set up with the materials for today. So there's a companion GitHub repository, which if you're not familiar with GitHub, search for me on GitHub. It's Walker KE is my username, and then find the my repository umish-workshop-2022. And so you can get up and running a couple of different ways. So GitHub, if you're not familiar, is the primary location where developers will host open source code, but you can also use it for a variety of other things. I actually host my book on GitHub. And so what you'll find here is all of the code that we're going to be using today, so you can follow along. You can find a link to the slides, and you can also find a link to an RStudio Cloud pre-built environment. So there are two ways that you can use the workshop materials today. If you're an advanced user who is already familiar with R and already familiar with RStudio and knows how to use Git, what you're going to want to do is clone this repository using the terminal command right here, and make sure that you have all of the packages installed. So just as a heads up, I just yesterday published a brand new version of Tidycensus to CRAN. So if you're an existing Tidycensus user, you're going to want to install that, because I noticed there was one feature with respect to 2020 census data that wasn't in the CRAN version, the published version. And so that's now updated. If you're getting any error messages, and I'll give you a heads up when that might come up, it's probably because you need the newest version. If you don't want to worry about that, or if you're brand new to R and just checking things out and you don't have R and RStudio installed, I have a pre-built RStudio Cloud environment available for you. And I'm actually going to be running the workshop off of that cloud environment. And so to get started, you have this rstudio.cloud link, and you can open up that link and it'll take you to RStudio Cloud. And so RStudio Cloud is a fantastic service provided by RStudio that allows you to run RStudio in the cloud. It's free to use. It has a tiered pricing option, but nothing we're going to do today requires that you sign up for a paid account. We're not going to be using it that intensively. So what you can do, if you already have an account, you can click log in, or if you don't have an account, you can click sign up. And you can sign up just with an email, a password, and first and last name, or you can authenticate with a Google account or a GitHub account if you already have one. I'm going to go ahead and log in with one of my many Gmail accounts and show you what things are going to look like for you if you use RStudio Cloud. So a couple of things. It'll take a few moments to deploy your project. This is copying over the pre-built environment that I have created for you to your personal RStudio Cloud area. You're going to see a bunch of code here, unfortunately, that I tried to clear out. First things first, go ahead and look for this little broom to clear the console and click that, and that will clear it out. The second thing that you want to do, you'll notice that it says temporary copy. This is a temporary copy of the project. What you want to do is save this over to your account. And so I'm going to click Save a Permanent Copy. And that is going to copy this project over to my personal RStudio Cloud space. And what we have here is a view of RStudio. What you have is the kind of default view. I'm going to move a couple of things around because I find it to be a little bit easier to talk through. If you look through this little window pane icon, I'm going to click there and I'm going to choose Console on Right. That's going to move my R console to the right-hand side, and it's going to give me a layout where I have a script editor on the left, a variables browser down here on the bottom, and then I have a files browser here on the bottom right, and then an R console on the top right. To bring up the code for today, there are two ways to do that. You'll see by clicking the Files tab, there's an Intro 2020 Census folder. If you click there, this will include all of the materials for today's workshop. I'm going to be working on this script called code.r. And if I click that, that will bring up all of the code that you'll need to run for today. If you prefer, you can also bring up the R Markdown file that I use to produce the slides. This is the source document that I use to produce the HTML slides for today. And you can actually run all of the code using R Markdown if you are familiar with R Markdown. I'm not going to work off of that today. I'm going to work off of this script, but you're welcome to do that if you have a preference for kind of the notebook style R Markdown format. For those of you who might be interested in making any additional modifications as well, you can click Tools, Global Options, and then click Appearance, and you can go and you can change the RStudio theme. You can choose the editor theme. For example, you might want a dark theme, and you can even choose the editor font. So there are a lot of modifications that you can make. I'm going to keep the defaults, but you're welcome to make any changes that you might want. So that's how we get set up with RStudio Cloud. And so let's go ahead and get started. So typically, a census data workflow involves going to the census website and using one of their data download tools. And the main data download tool available from the Census Bureau is data.census.gov, where you can go in and you can filter data and make queries and make selections based on geography and variables that you want, and then export that data out as an Excel spreadsheet that can be analyzed in an Excel environment. And that's typically the workflow that I commonly would work with, mostly with the old American Fact Finder website. And eventually, kind of as I got more and more into working with R, I wanted to think through ways that this process could be automated. And I came across some resources and some packages for working with something called the Census API, or Application Programming Interface. So data.census.gov, which again is your kind of data browser and general download client for census data, it's your main portal. It's powered by the US Census API, which is a resource that's set up by the Census Bureau to allow census data to be accessed by developers programmatically. It is a wonderful resource. And one of the great things about the API, it's set up to be simple enough that a number of developers working across a number of different software platforms have themselves written software and software packages that facilitate access to these resources. So inside of R, there are multiple packages that interact with the Census APIs. Kind of the ACS package was the standard bearer in this area for a number of years. The Census API package is a really fantastic package that I use heavily that accesses all of the APIs available from the Census Bureau. We'll be focusing today on my package, Tidycensus, which takes an opinionated approach to accessing a select number of census APIs. If you program in other languages, the CenPy package in Python is great for working with census data in Python. And then there's the City SDK package in JavaScript for accessing the APIs. So Tidycensus is a package that I first wrote 5 years ago in 2017. Really the beginnings of the package I wrote just about 5 years ago, that gives access to a variety of Census Bureau APIs. It doesn't give access to all of them like Census API does, but really focuses on facilitating access in R to a select few. So it gives access to the Decennial Census and American Community Survey datasets. It also gives access to the Population Estimates Program, which has information on yearly estimates and components of change. It accesses the Public Use Microdata Series APIs, and also more recently, the Migration Flows APIs. And my intent in developing Tidycensus was try to make relatively time-consuming and tedious processes much more concise, so that specifically me at the time, but then users more broadly could get to their analysis faster and ideally spend less time working on repetitive and maybe less interesting tasks. And so Tidycensus tries to do a lot of this data setup for the user. It pulls data down from the Census API and gives it back in a custom format, a format that's either tidyverse style or that is sort of traditional wide form with variables in the columns. I'll show you what that looks like in a moment. The big reason why I developed Tidycensus was because it can automatically merge census geometries to data to facilitate mapping. This is something that typically took me a lot of time. And now it's very, very quick. So I'll show you how to do that in next week's workshop. It also has a number of other helpful tools. In the final workshop of this series, we'll focus on ACS data. It has built-in tools for working with margins of error in the ACS. And one of my favorite features since I first started writing this package, I could never remember the FIPS codes of any location that I wanted. I can basically now remember Texas is 48 and Alabama is 1, and that's pretty much it. But with Tidycensus, you don't need to put in the FIPS code of a state or a county. You can actually request it by name. So with respect to kind of the history of Tidycensus, it's one of those interesting things. I think when I talk about why it's useful to get into developing software, because I never really saw myself as a software developer before starting to write these packages, I was assembling a bunch of scripts where I was doing the same thing over and over again. It would talk to the Census API, pull the data down, pull in a census shapefile, merge it together. And I was just running those scripts over and over and over again. And so I ended up thinking, could this be a package? I read Hedley Wickham's book on developing R packages, wrote some very early implementations, little clients to access what was at the time the 2010 to 2014 ACS data. And then really the R ecosystem evolved around it. I got some great support from Matt Herman in particular, who's a co-author on the package, to build out access to the data sets that frankly I use most heavily, but the user community has really embraced this package. Tidycensus has been downloaded approaching 250,000 times, which is really cool to see, about 10,000 times a month. And so it's been fantastic to see the uptake in the community. All right, so let's go ahead and get started. If you are working off your own computer and you don't have these packages installed, these are the 4 that you're going to need: Tidycensus, tidyverse. And then later in the workshop, we'll work with some custom visualization implementations, which will use the GeoFacet and the ggRidges packages. So go ahead and install those if you need to. Again, I would recommend updating Tidycensus. So Tidycensus was just published. The new updates were just published yesterday to CRAN. You should be able to install them. If there are any hiccups at all, which may come up, I'll talk through that. Or you could use the RStudio and Cloud environment, which is already set up for you. So you don't need to install these packages in RStudio Cloud. Those are pre-installed for you. To get started then, and JP mentioned this, what you'll need to get is a Census API key. And so if you don't have a Census API key yet, what you're going to need to do is visit this link, which was also provided in the setup, or you can frankly just Google Census API key. And it just takes a couple minutes to get. Census has really streamlined the process of getting a key, which is great. And you can use this code in Tidycensus to set your key as something called environment variable that R will pick up. So for users brand new to R, once we have installed our packages, we are going to load the Tidycensus package into our R session using the library command. That gives us access to all of the functions that we're going to be using in Tidycensus in this workshop. The Census API key function is one of those functions. And so where I have the text, your key goes here, that's where you'll input your key. You'll notice if you're using RStudio Cloud, I've actually included a sample key that I've pulled down for the purposes of this workshop. You are welcome to use that. If you're planning to use Tidycensus or the Census API, in the future, I would strongly recommend getting your own key and not using this key. And so what you can do here is, I have this code commented out, but I'm going to delete these little number signs to uncomment the line. I'm going to run this code. And so for those of you who are brand new to R and RStudio, a brief primer on how you run code, because this is going to be something that we're going to be doing throughout the workshop. If you highlight a line of code in your script editor, you see how it turns blue. You can click this run button to run that code, or you can use the keyboard shortcut Control Enter to run that code. When I click run, that command is sent to my R console and executed by R. So I have just run the code library tidycensus to give me access to all of the functions and functionality of the tidycensus package. The census API key function will set this key as an environment variable. And what that means is that every time that you request data from the census API, you can, I see one mention in the chat, if you're in the cloud, do you use my key or do you use your own? It's up to you. You can use my key if you want to, but it's probably a good idea to practice using your own key. So what you would do is you would replace this key with your own key you've obtained from Census. It'll work just the same. This key, there's nothing special about this key. I just wanted to provide it in case anybody had trouble getting access to their own. The install equals true is instructing Tidycensus and R to basically write the key to a special file called .renviron that will in the future get picked up every time that you come back to use R. If you change this to install equals false, the key will be set for use throughout your R session today, but won't be remembered the next time you come back. So for example, if you had install equals true and you ran this, I'm going to show you how that works. It says your API key has been stored in your .renviron file. To use now, restart R or run this command. So I would need to restart R to use my API key and then reload Tidycensus. So to restart R, if you're following those instructions, you would click Session, restart R, and then you're going to want to rerun the library tidycensus command. And this is the only time that you need to do this, because now your census API key will be remembered in future sessions. So that gets us set up. Now I want to show you some basic functionality of Tidycensus with a focus on the 2020 decennial census data. So let's talk a little bit first about the 2020 census data, specifically what we have access to now. So the 2020 census is, for those of you who are familiar with census data, it's been, there are a number of kind of unique elements to the 2020 data that haven't characterized previous decennial censuses in the specific way that we're going to be discussing here. So the 2020 census data that we have now, obviously 2020 was a complicated year in the United States, going through the COVID-19 pandemic. The Census Bureau was faced with, in some cases, budget shortfalls, funding issues, and just general challenges in conducting a census during a pandemic. And so the data release has been delayed relative to previous censuses, but we do have 2020 census data from the PL 941-171 redistricting summary file. That is the data that is used specifically for congressional apportionment and redistricting. So the redistricting process has been going on. We just had primary season down here in Texas with the new newly drawn congressional districts. Some other states, we're seeing that those are being litigated in court right now, but those are based on this redistricting data that we can use. What that means is we don't yet have all the variables that we typically get with the 2020, with a decennial census. So we have total counts, population and households, we have occupied and vacant housing units, and then we have total population and voting age population breakdowns by race and ethnicity. And then we also have group quarter status. So later this year, it hasn't been announced when yet, we'll be getting the demographic and housing characteristics summary files. That's going to be a little bit different from the previous, say, summary file 1 or summary file, well, we had summary file 3 way back in 2000, but in 2010, we had summary file 1. That's going to be updated for 2020. And we're expecting to get more variables such as age and sex breakdowns, more detailed race and ethnicity. It's still not 100% decided what we're getting, but that's something that we're going to watch out for this year. And when it comes out, Tidycensus will support it. So let's take a quick look at getting 2020 census data from Tidycensus. So for any decennial census that's available from the Census API, you'll use the get_decennial function. So we can use it to get census data from 2000 and from 2010 and now from 2020. The default year in get decennial, because we don't have the full 2020 decennial census yet, still is 2010. So if you want 2020 census data, you have to explicitly say year equals 2020. So all you need to do to get data from the 2020 census in Tidycensus is run the get decennial function with these 3 arguments. You'll need a geography, and I'll explain census geography in just a moment. You'll need variables. I'll explain those in just a moment as well. And then you'll need year equals 2020. So when you run that, and I'm going to jump over to R and step you through what all this means in just a moment, you'll see something that looks like this. It returns a tibble, which is a stylized R data frame that works well with the tidyverse suite of tools. And you'll get back 4 columns. The first column is GOID, which is going to be the FIPS code or the census ID code representing that geographic unit. You're going to get a name, which is a descriptive name of the location. You're going to get the variable, that's the census variable code. So P1_001N is the code for total population in the 2020 census redistricting file. And then you'll get a value, and that's going to be your population count. So I'm going to jump back over here. I'm actually going to close this out. I'm going to jump back over to our Studio Cloud and show you how this works. And so for those of you who are brand new to R, just briefly, I'd like to step you through what we're doing here. The pop20 is an object that I'm creating in R. This is going to be an object that stores the decennial census data that I'm requesting. And to create an object in R, you use something called assignment. And assignment in programming is the process of running an operation and then giving the result of that operation to an object. And so you can think of it as, I'm going to create an object named pop20, and I'm going to assign to it the result of this command. And the command is called a function, and the function is named getDecennial. Functions have something called parameters, and parameters are going to be components of the function that can vary based on user input. And getDecennial has a number of parameters. We're going to explore several of them today. The parameters that we're using are geography, which is going to be the level of aggregation that we want. Variables, which is one or more census variable codes representing data we want. And then the year, which for the purposes of today, which will always be 2020 with one small exception. So I'm specifying geography equals state because I want state level data. I'm using the census code in the redistricting data for total population, which is P1_001N. And then I'm using year equals 2020. To run that code, I highlight the entire block of code, and then I can click run. And you can see here that my query has succeeded. So I can take a peek at POP20 by typing that in, and you'll see exactly what was in the slides. So you get some messages here, and I want to talk you through what those messages mean. So you'll see these messages that print out when we run Get Decennial for the first time. You're not going to see that print out again until you go away and then come back and use R in a new session. So the first couple messages will always print out getting data from the 2020 Decennial Census, so you know where things are going from. And so Mary, I see in the chat, if it says could not find function, what you'll need to do is rerun library Tidycensus again. Anytime you see could not find function, it means that particular package is not loaded. So just make sure that you run library Tidycensus again, and then it should work. And then it tells you which data set it's coming from. So we're using the PL 94-171 redistricting data summary file. We also get this message. You'll see that over here in our note. The 2020 Decennial Census data use differential privacy, a technique that introduces errors into data to preserve respondent confidentiality. Small counts should be interpreted with caution. And then I provide a link to the census website where you can learn a little bit more about what differential privacy is. The message is only displayed once per session, so it doesn't print out every time you run Get Decennial. Differential privacy is something as a user of the 2020 census that you need to know about. We haven't used it we've used kind of different methods in the past to preserve respondent confidentiality. Differential privacy is a method that's being used in 2020 to satisfy US Code Title 13 requirements, which it basically, in a nutshell, is kind of covering the mandate of the Census Bureau to preserve the absolute confidentiality of responses to the US Census. So differential privacy is a concept coming from computer science that introduces noise or intentional errors into data in order to try to make it difficult, if not impossible, for developers or for someone to basically reverse engineer the census and identify individuals from census data. And so this has an impact on the accuracy of small area counts. So you'll find census blocks in the 2020 census data, for example, where there are children, but no adults. So we've heard those referred to as Lord of the Flies blocks. Those are not because there are actually no adults there. It's because you're going to be seeing the effects of differential privacy. And so this is a matter of active debate in the user community at the moment. Advocates are arguing that to satisfy Title 13 requirements, given modern database reconstruction technologies, that differential privacy is absolutely necessary. But a number of critics in especially kind of the applied social sciences have been contending and doing studies that the method simply makes the data less useful, but it doesn't really come with a tangible privacy benefit. And so this is something that's being actively debated. A lot of interesting articles that can be read about it, but it is important for you to know if you have very, very small counts, those are going to be noise infused. If you're talking about total population at the state level, don't worry about it. Like those are going to be accurate. But when you're getting down to small geographies for smaller population groups, that is something to be aware of. So what we have done first and foremost is we've requested a single variable from the census using Get Decennial. If you want a bunch of variables, you can use the table argument instead. And so if I specify instead of variables equals something, I can grab an entire table from the decennial census, such as table P2, which is one of the tables in the census, which is race by Hispanic origin. And what that will do, if I run it, you'll see here, is I will pull down all of the data in table P2. And if you were to explore this a little bit more, it grabs all of the variables inside of table P2. If you haven't updated Tidycensus recently, this won't work. So I pushed a fix just yesterday to make sure that this works. So you might need to reinstall Tidycensus from CRAN if you haven't updated in a while. If you're in our Studio Cloud, you'll be fine. So you'll notice here that the POP20 object is a 52 by 4 tibble. So it has 52 rows. So that includes by default all 50 US states plus DC plus Puerto Rico. Here we have 3,796 rows. That means that we have data for each of those 52 states and state equivalents for all of the variables in table P2. I mentioned before that one of my primary intentions in developing Tidycensus was to make it easier to request data, census data by geography. And geography, I'm going to talk you through these two parameters and get decennial that we've introduced already. There are a lot of different geographies at which you can get data. We can call them sort of enumeration areas. And so these are different geographies at which data are tabulated. And so I noticed, Vishal, you said the Census API request is unfortunately taking a while. Feel free to hop onto our Studio Cloud and use my key if it's taking a little long. And then when it does come back, hopefully it'll come back pretty soon. You'll be able to come in and use your own key. But you can feel free to use the one that I provided in our Studio Cloud if you'd like. These are all areas at which the census aggregates data. And so the core census hierarchy is going to be this central axis of the diagram. And it starts at the census block. The census block is the smallest geography at which you can acquire data. Blocks are really analogous to a city block in many cases. Census blocks nest within block groups. What that means is that every block group, which is a slightly larger geography, is entirely composed of census blocks. So census blocks do not cross block group boundaries. Block groups will have generally around maybe 800 to 1,500 people or so, give or take, though that can certainly vary. Block groups then make up census tracts, and census tracts are a pretty common geography that are often used as a proxy for a neighborhood. And census tracts typically have around 4,000 people. And just as a heads up, census tracts, block groups, and blocks are all redrawn with each decennial census. So block census tracts for 2000 are going to be different than census tracts for 2010. And different for 2020. Census tracts then roll up within counties, and counties are different from census tracts in that they're both census enumeration areas where we tabulate data, but they also have legal jurisdiction in the US. Counties then nest within states, and then we have divisions, regions, and the nation. Outside of that core hierarchy, we have a number of other enumeration areas that don't necessarily fit within the central axis, but nonetheless are significant for a number of applications. For example, zip code tabulation areas, which are proxies for zip codes. We have voting districts, which are very useful for redistricting analysis, school districts, congressional districts. And in Tidycensus, you can get access to all of these. You can take a look in my book or in the Tidycensus documentation for how to format those different geographies when you're requesting data from the census. And so beyond that, I mentioned before that I was tired of looking up FIPS codes because I never could remember I could never remember them outside of the state I lived in at the time. And so what Tidycensus will do, it'll translate state names and state postal abbreviations internally, so you don't have to remember the FIPS code. I don't remember what the FIPS code for Michigan is off the top of my head, but I can just put in state equals MI, and I can grab data, in this case by county, on the Hispanic population in Michigan. I can additionally subset that down. So you'll see this result. We'll come back to that, and I'll show you that in R in just a moment. You can also query by county for geographies below the county. And so in this case, I'm saying geography equals tract. I specify a specific variable. I do Washtenaw County in Michigan, where Ann Arbor is located. And I can grab data, in this case, at the census tract level for a specific county in Michigan. So to show you briefly how this works, I'm going to run my Michigan Hispanic code. And you'll notice that I get this message. I'm grabbing data from the 2020 Decennial Census. It's letting me know that I'm using internally, I'm doing the translation to FIPS code 26 for Michigan. And I can take a peek at my data. And I see here that I get data by county for Michigan. Similarly, if I'm grabbing data for Washtenaw County, that will work accordingly, and I can pull down now by census tract. So that covers geography. I want to spend some time talking now about variables. This is maybe kind of one of the hardest things to figure out when getting started with Tidycensus. And I even just noticed there was a new R package called Easy Census that wrapped Tidycensus with a potential solution to this issue. What I implement in Tidycensus is a variables browser that allows you to pull down the variables from the census website and browse them interactively. And so the load variables function in Tidycensus requires a year and a data set name. And the only data set available for the 2020 census at the moment is PL for the PL 94171 redistricting file. So if I run that code and create an object, I'm naming vars, that will store all of the variables. Let's see, that will store all of the variables in this vars object. I can use the view command in RStudio to interactively browse those variables. So let's go ahead and try that out. I run that code, and now I have a variables browser with the census code, the census label, and then the concept. That's going to be the general, basically, concept or table that you're working out of. So we see here that we have some housing unit variables, H1_001N. That's going to be total households. Just a heads up, total households does not use differential privacy. So the total households number that you grab from the 2020 census is the actual number of households in any geography. It is not noise infused. The population data are noise infused, but the total households information is not. So just something to be aware of. But I can browse through and I can see I have race information. So this is population of one race, white alone. We have a number of other race breakdowns, and you can hover your cursor over these different labels to view the full definition here. And we can scroll down even more. You'll see there are a lot of variables available, about 300. And now we have information on Hispanic or Latino by race. That's typically what you'll use when you're analyzing race ethnicity data. If you want, you can also use this search box. If I want to say, I specifically want Hispanic, this will filter down for all of those variables that have Hispanic in one of the columns. Or you could click the filter button right here, and you can search in any of those specific areas. And eventually you'll get a feel for which variable codes you'll want to use. The tables that are available in the 2020 Census PL file, so what you can supply to that table argument if you want to grab all of those variables for each table. So we have 6. H1 is going to be occupancy status by household. P1 is going to be race. P2 is going to be race by Hispanic origin. P3 is then race for the population 18 and up. P4 is race by Hispanic origin for the population 18 and up. And then P5 is going to be group quarter status. So that's the data that we have available, and you can pull that down. A couple other things that I want to go through before we break. So we may go a little bit closer to noon Eastern time before we break here, given that we spent a little bit more time in the introductions. But I want to cover a couple pieces with respect to data structure in Tidycensus and how you can get data in a format that really works for the analysis that you want to do. So by default, Tidycensus is part of the reason it's named Tidycensus is it's designed to return data in a format that works well with tidyverse tools. And the format that is typically used for tidyverse analyses, which you will be working on in hours 2 and 3 of this workshop, is long form, where you basically have data in which census variables are going to form geographic unit variable combinations that are represented in each row. And so in this case, geographies will be stacked by row. So if I want to grab all the data on group quarters from table P5 for states, I'll get something that looks like this, but I want to illustrate very briefly exactly how this works and how it looks and how you can browse your data in greater detail. So I'm going to hop back here to our Studio Cloud. I'm going to rerun that code that pulls down table P5. But one thing I want to show you here, I can type into my R console view group _ quarters. And now I have a browser for my data. And what's interesting about this is I can actually sort any of these columns. So if I wanted to sort on name, you can see here that each row is a unit variable combination. So this row represents Alabama for P5001N, and that's the value. Now this is Alabama for P5002N, and this is the value. And so I actually have several rows for each state. So this is the tidy data model, or long form data, which it's called in other sort of application areas. Not all analysts want their data in this format, and I commonly get this request. This has been baked in from the beginning, but people don't always see in the documentation that you can request data in what's called wide format, which a number of analysts, if you're coming from, say, statistical software, or if you're coming from geographic information system software, you might be more familiar with wide form data. And wide form data is where each variable, each census variable, has its own column. And then each row is going to be a single geographic unit like a state. And so what I can do here is, if I jump back over to our Studio Cloud, I can create this new object called group quarters wide. And you'll notice the structure of it. I'm actually going to view group quarters wide. And you see it's the same data, it's just in a different format. It is with the variables spread across the columns. So it's wider, it's wide format. And so in this case, Alabama, I can sort based on the name. Alabama has this one row. It doesn't have several rows for each variable. It has one row, and the variables, instead of being in a column called variable, the variables are spread across the columns, and each census variable here gets its own column. And for a number of applications, statistical modeling, or maybe some GIS work, this might be an ideal format for your data. And to get data in that format, use the argument output equals wide. So the default, which you don't have to specify, is output equals tidy. You don't have to type that in if that's the format that you want. But if you want output equals wide, and so if you want output equals wide, then you're going to want to specify that specific argument and get wide form data. If you know what variables you want and what they represent, wanted to show you something here. If you want multiple variables but not a full table, you can specify a vector of variables. And vectors in R, if you're not familiar with R, are formed with the C function and separated with commas. And what the C function does is it creates something called a vector, which is an object that can have multiple elements. So in this case, the object that we're passing to variables is not a single string of census IDs, but rather it is multiple census IDs. And what getDecennial will do is it will fetch data for all of the census variable IDs that you were asked for and give you back the appropriate data. If you don't want to have those ambiguous census ID codes in your output data set, you can use something called a named vector, which you can see here highlighted on the screen, where you tell Tidycensus, this is what I want the variables to be called. And so in long format, those custom inputs will populate the variable column. And then in wide form, they'll actually replace the column names. So I want to show you briefly how that works. If I run this to get vacancies wide, and so this is getting information on vacant households and total households for counties in the state of Michigan, I'm specifying output equals wide, meaning that I want the variables to be spread across the columns. If you look at my output, I actually now have two columns that are renamed automatically with the names that I specified when I was asking for data. And so instead of having H1_003N, I have vacant households. And instead of H1_001N, I have total households. And that can be potentially a little bit easier to work with. So that concludes part one of the workshop. Basically, what I had in mind was taking about a 10-minute break. One thing that I want to address, though, before we break, I see that Shannon had a question that I anticipated coming up. It is likely that if you're getting that error message, that Tidycensus needs to be updated. So if you run install.packages tidycensus, it should pull down the new version of Tidycensus from CRAN. That error would be coming up anytime that you're trying to use this table argument. So the new version of Tidycensus should fix that. If for some reason it doesn't, and Deb, I'll show you how you would do that. In your R console, you could type in install.packages tidycensus. Don't do that in RStudio Cloud. That will, your RStudio Cloud is ready to go. I don't mess with the RStudio Cloud environment at the moment. Or at the very top, I have that code in the script that shows you how to install packages. If for some reason it's still not working, go use the RStudio Cloud environment because that's already pre-configured for you. So let's go ahead and break for about 10 minutes. We'll start up maybe kind of 10 minutes after noon. This is a good time right now to do a couple things. I've got a couple exercises available for you that you can work on here. One is take a look at the available geographies in Tidycensus from its documentation. Try using a geography that we haven't yet used and pull some data down on total households using what you've learned. And the second exercise, use load variables to find a variable that interests you. And then try using getDecennial to grab data on that variable for counties in a state of your choosing. And so just spend about 10 minutes working on those exercises, stretch our legs a little bit, and feel free to ask any questions as well. JP will be fielding questions, and we can spend a few moments when we boot back up again answering some of those questions. So I'll see you back here in about 10 minutes.
Just to reiterate what Kyle just said, please feel free to use the Q&A function. You should see it at the bottom of your screen to ask us any questions. You can put your questions there, and we'll look forward to answering those in a few minutes. All right, everyone, we're going to get started in just a few more seconds. If you have any other questions, please feel free to put them in the Q&A. All right. Before I field the first couple questions to Kyle, I just wanted to point out we've seen a few people having some problems, some technical issues. Kyle is going to address a few of those that we've seen and that we are able to quickly identify what the issues are. I will say that if you are having issues that we are not immediately able to resolve, the session is recorded and we will be posting the video soon. So if you want to follow back up and try in the next few days, you'll be able to do that as well. We hope to try to resolve some of these issues right now, but if we're not able to resolve those, please know that the session will be recorded and you'll be able to go back later as well. So Kyle, the first question that we had was whether lower level data or data for lower level geographies like census tracts, whether those data include the geographic identifiers for some of the higher level geographies that they are nested within. So for example, if you request data for census tracts, will it identify the county and state that those tracts are in?
Yeah, that's a great question. And I have actually an example a little bit later in the workshop to show specifically how to work with that. But as a bit of a preview, I'm going to jump back over here to our Studio Cloud and revisit this example here where we grabbed census tract data for Washtenaw County for the Hispanic population there. So basically this object, Washtenaw Hispanic, you'll notice here a couple pieces. We get by default the GUID and name columns. Those will always come through. And the way that they're structured, both of them from the Census Bureau, is that they include all of the information for the parent geographies in both of those columns. And so let's take, for example, this first census tract. If you look at the GUID, interpreting GUIDs, and if as a follow-up, I have a section in my book on interpreting GUIDs that I would strongly recommend that you take a look at. It's in chapter 2 of my book. This looks like a bunch of numbers, but it's actually quite meaningful. The first 2 digits of your GUID for any geography that comes back that nests within a parent geography is going to be the state code. So the state FIPS code for Michigan is 26. And so you can see it's 26 for all of these tracts. The next 3 digits, that's going to be your county code. In this case, it's Washtenaw County, and that's 161. So FIPS codes for counties, they'll be unique within states, but not unique across states. So if you need a unique county identifier, you'll take these first 5 digits, 26161, uniquely identifies Washtenaw County among all counties in the US. And then the census tract code is the next 6 digits. So that in this case, this is census tract 4001. You'll have 400100. And so generally speaking, census tracts will be right padded with zeros. For special cases like this tract here, 4022.01, you'll notice that the 6-digit code is 402201. And so you can parse that to get the information about the parent geography. What's interesting about it, if I type in, and this is some code I haven't introduced yet, but just to show you the first, what the first element of the name column looks like. So this is this full kind of string that represents kind of, that's not completely printed off here. You have this information in the name column for all of the census tracts. You have the census tract name, which is 4001. You then have the county, Washtenaw County, and then you have the state spelled out in an interpretable way. And what we're going to learn how to do in just a little bit is actually parse this and separate it out based on where the commas are into separate columns. So you can actually create a county column and a state column relatively seamlessly. So we'll get to that in just a moment.
Great, thank you. And then the next question we have is whether there's a difference in the availability of data at different geographic levels. So are there some data that are not available, say for at the block level or at the block group level, or census tract level, et cetera?
It's a great question. For the 2020 census, all of the variables that you see in the when you do load variables, those are available at every geography. Every geography that is available for the 2020 census right now. That will likely change. So when the demographic and housing characteristics file comes out later this year, it is likely that there will be variables that are unavailable at some geographies. So in this specific case for the redistricting data file, it's all of those variables are available at all geographies, but that's sort of a unique circumstance. The full 2020 census data will not be like that. But it hasn't yet been decided. And part of that is a privacy issue. Census is deciding, should we release all of the data at every geography? We'll focus in the third workshop on American Community Survey data as well, which is where you get a much richer set of variables. That one is another example of where not every variable is available at every geography. So it really depends on the data set.
I saw that there are a couple questions that I can answer that have to do with the recording. And I just wanted to point out that everyone who registered for this session, we will send out an email in the coming days when the recording is available with the location of where it will be posted. So please look out for that in the next few days. Again, that recording will be sent out by email and posted on the SSDan website. There are two other fairly quick questions that I saw just came in that I'll post to you, Kyle. One is whether PUMA geographies, that is a public use microdata area geography, is available using Tidycensus.
It absolutely is. So you can pull aggregate data by PUMA. I would need to double check and make sure that it's available for the 2020 redistricting data. But any of, and just to show you here, if you go to the Tidycensus documentation, which is here, you'll see this table of all of these different potential geographies that you can use. And you'll use this specific character string to request data. PUMA data is a little bit different, in part because, and we can see here that I have it only listed as available for Get ACS. I know that PUMAs, and this is something that's sort of, openly being discussed right now. Right now, the PUMA data or PUMS data, so micro data, are only being released for the American Community Survey. It is not clear if there's going to be a decennial census microdata data set. And so I would need to double check on that one. It's something I haven't personally checked on. But that's something during the next break, I'll actually look into it and then follow up on that.
Great. And then the last question is whether the different federal agencies use a consistent set of geographic identifiers. So does BLS, USGS, do they also use the same sort of geo-IDs?
So those geo-IDs are going to be specific to the Census Bureau. If they're using US Census geography specifically, they will likely use those IDs. But I have seen from BLS kind of a different set of geography identifiers in some cases. So it's Ideally, yes. Generally speaking, yes, but it's not going to be 100%.
All right, thank you very much. We'll let you go ahead and get started on the second hour.
Okay, fantastic. And thanks everybody for your questions. And looking through this, and even seeing stuff like participants responding to other participants. That's fantastic. So what we're going to cover in this second section is how to actually explore your data and wrangle your data using tidyverse tools. And so for those of you who want more in this regard, this is a little bit of content that's coming out of chapter 3 of my book. And so a Tidycensus is named as such because it is designed for use with the tidyverse suite of tools. And the tidyverse are a set of R packages that are designed for exploratory data analysis and data wrangling and kind of data manipulation that are very, very popular. They were invented primarily by Hadley Wickham, who's chief scientist at our studio. They're maintained by a large team at our studio who works on these packages. And Tidycensus, again, one of the main goals was to kind of integrate an approach to census data with the tidyverse. And so we're going to go through a variety of functions in the tidyverse that can be used for census data analysis. I just mentioned briefly here in this slide, commonly when you pull down census data, it's in wide format. Tidycensus takes an opinionated approach to this because tidy tools in the tidyverse are really designed to work with long form data. And that's what Tidycensus tries to do. So let's take a look at some of these tools. We're going to work through a series of functions that are available in the tidyverse. And just to explain really what the tidyverse is, when you use library tidyverse to load in tidyverse, the tidyverse, I want to show you that briefly. So we're starting here. And when we run library tidyverse, you'll notice here you get this message that says you've actually loaded in 8 packages. The tidyverse is what's called a meta package in R, which is a convenient way to load in multiple packages that typically work together in a particular workflow. And so the 8 packages that get loaded in include ggplot2 for data visualization, which we'll be focusing on in the 3rd hour of the workshop, Tibble for easy display of data sets, tidyr for data reshaping, readr for data import and export, per for functional programming and iteration. I'll show you an advanced example of that later in the workshop, dplyr for data wrangling, stringer for working with text, and forcats for working with a special data type in R called factors, which we won't be covering today. And so this gives us access to a number of functions for data wrangling, which are very, very useful. And so let's grab some data just for starters to do some exploration. So I'm going to run this code to pull down data on population, total population by county in my home state of Texas. So I pull that down, it comes in very quickly. And if I want to, I can view that object. And the data set has 254 rows, and it has information for all of the counties in Texas and their populations for 2020. So using tidyverse tools, you can ask a variety of questions, such as, what is the largest value? What are the largest values? Or what is the smallest value? What are the smallest values? The arrange function, that is your core sorting function in the tidyverse, and it belongs to the dplyr package. And what arrange lets you do is, based on a value in one or more columns, you can sort your data. So if I wanted to go in and print out the largest counties or smallest counties in Texas by population, I can use the arrange function on my tx_population object and sort my data accordingly. So if, for example, by default, I say arrange my Texas population object based on the values in the value column, it will by default sort my data in ascending order of value. If I want descending order instead, I add this DESC function, desk function for descending, and I wrap value inside of that. So this is basically saying arrange, so sort my Texas population data set in descending order of value. So let's go ahead and try that out. I run this code and I can see here, I'm actually gonna clean this up a little bit, that by default, I printed out the 10 smallest counties in Texas. And Texas is pretty well known for, one, having more counties than any other state in the country. We have 254 counties here, and a lot of those counties are very, very small. So we're home to Loving County, which is tiny, 64 people as of the 2020 census, and a number of others that are quite small. We also have some of the largest counties in the country in Texas. And so if I arrange in descending order of population, I get the opposite. So Harris County, which is home to Houston, has 4.7 million people as of the 2020 census, making it one of the largest counties in the entire United States. And I see we have a participant here from Harris County representing for Texas. You'll note my county, Tarrant County, comes in third at 2.1 million. And then we have Dallas County, where Dallas is at 2.6 million. And Bexar County, which is San Antonio, at just over 2 million. So Travis County, which comes in fifth, that's Austin. And so we have several counties above 1 million in Texas, and then we have several counties with very, very small populations. And if you want to subset your data even further to try to answer some of these questions, you're going to use the filter function for that. And so for those of you who come from a database background where you're familiar with SQL queries and you're subsetting your data, say with a where clause, the filter function replicates this functionality. And so with filter, what that does is it basically says for a given data object, which in this case is Texas population, and a given clause. So in this particular case, I'm specifying a condition which can be checked by row, whether it is true or false. And so if the condition evaluates to true, then the data will be returned. If the condition evaluates to false, the data will be dismissed. And so in this particular case, we're creating a new object that we're calling below 1,000. It's going to represent only those counties in the state of Texas with a population below 1,000 people. And it knows to do that because of the expression that we've set here. Value is less than 1,000. So there are a variety of different conditional operators that can be used in R. I'll walk you through some of the most basic ones if you want to fiddle with this a little bit. I'm going to go back here and show you briefly how this works. So I am filtering my Texas population object for rows that have a value in the value column less than 1,000. And I can run this and I get back 8 counties in Texas that have a population smaller than 1,000. And so Texas, especially out in West Texas, we have a lot of counties that are very, very tiny. So you'll notice we use the familiar less than operator to specify that. For those of you who are new to R, there are a variety of different operators that you can use. The most common ones that you'll use will be less than, or greater than. So for example, if I wanted to do filter TX population value greater than, let's say, 1 million, I get back the 6 counties in Texas with a population greater than 1 million. This won't be useful in this context all that well, but if you want to test if something is equal to or is not equal to a value, so is equal to is a double equal sign. That's going to check to see if something is equal to something else. And then not equal to is going to be exclamation mark equals sign. So that's how you test to see if it's not equal to something. For total population values, you'd probably pretty rarely put in population is equal to 1 million because it's going to be pretty rare that you're going to find that value. But in many cases, you will want to know that. And so if you're new to R, you can use filter accordingly. All right, so now you've gotten a little bit of a sense on how to subset your data and how to explore your data a little bit. In many cases, however, you're going to want to derive new data from existing data. And a common use case for this is calculating percentages or proportions. For example, if you have a state like Texas, where you have counties ranging from 4.7 million to 64 people, making clean comparisons across counties becomes difficult because Harris County has a massive denominator for any metric in the census that you're going to look at, whereas some of these smaller counties in West and South Texas, their denominators are tiny. And so you can't make clean comparisons between the counts all that well. And you're going to want to adjust your data or normalize it based on the underlying population size. And so in this particular case, you're going to want to create a new column. And I'm going to show you a workflow for getting that to work. I have built-in functionality into Tidycensus to create something called a summary variable. And in many cases in your data tables, the first variable will represent a summary variable. And just to reiterate, and I want to show you this very briefly because I've gotten a couple questions about it. If you're trying to pull data on variables, you have to put in the name of the data set. And in this case, for 2020, the only data set that will work for 2020 right now is PL, lowercase PL. That is your PL 94171 redistricting data that we're working with right now. So notice I just got a question about that. If you're putting anything else in here, that will not work. So if you run this and you take a look, you'll notice that the first variable in each table is typically a total. So we have total households, total population again for P2, and so on and so forth. That's going to be your appropriate denominator. With tidyverse tools, we can, in a relatively straightforward way, calculate percentages based on collecting numerators in one column and putting a denominator in another column. So let's talk this through a little bit. We're going to look at counties in the state of Arizona. Arizona has very few counties, so it's a little bit easier to compare across counties in Arizona as opposed to Texas. What we're going to do here is we're going to use that trick that we learned at the very end of part 1, where we collected a series of variables and named them and assembled them in a vector. So this object in R that can contain multiple elements. And so we're basically saying, I want to get data on race and ethnicity for Hispanic population, we'll call it Hispanic. For non-Hispanic white population, which we'll call white. Non-Hispanic black, which we'll call black. Non-Hispanic Native American or Alaska Native, which we'll call native. non-Hispanic Asian, which we'll call Asian, and then non-Hispanic Hawaiian or Pacific Islander, which we'll call HIPI. And so we can do that and then pass that vector to the variables argument here, but we're using a brand new argument here called summary var. And what summary var does is it takes in a single variable that we want to use as a denominator. And what it returns is an extra column that's called summary value. So instead of having a single value column and say putting total population as equivalent to say Hispanic or Black or white, we get a second column here, which allows us across groups to seamlessly create proportions or potentially create percentages. And so to show you briefly how to do that, I'm going to go ahead and run this code just to catch us up here. And you'll see how that works. We have now 5 columns instead of 4, and I have a value and a summary value column. So you can see here for Apache County, there are about 3,800 Hispanics in Apache County in 2020 of a total of about 66,000 people living in the county. So it becomes then relatively straightforward to calculate percentages. So how do you do that in the tidyverse? To create new columns in your data in the tidyverse, you'll use the mutate function. And the mutate function takes an expression such as 100 times the result of value divided by summary value and gives that to a new column, which we're calling percent. The select function then can be used to subset your data across the columns, where in this case it says keep in the resulting data object the name, the variable, and the percent column and get rid of the others. You'll notice this funny looking operator here, percentage sign greater than percentage sign. That is a pipe operator. Piping is a concept that you'll find across a variety of different programming languages that allows you to string multiple commands together instead of having to basically write out each command in its own separate kind of line of code. It can take a little time if you're new to R to wrap your mind around how this works, but I want to talk you through it. You can interpret the pipe operator as the word then. And what the pipe operator does is it sends the result of the first line as the first argument to the next line. So let's talk this through. We're basically saying, create a new object named AZ race percent. We use the assignment operator here, the arrow sign. And we're creating that from the existing AZ race object, where we take the AZ race object. Then we mutate that object to create a new column named percent that is a result of this mathematical expression where value is divided by summary value, then is multiplied by 100. So if you're doing math in R, it will obey the order of operations. So just make sure you use parentheses if necessary. Then from that object, select the columns name, variable, and percent. And so if you're struggling a little bit with interpreting the code, try reading this as if then, and then talk through it. And it starts to make a lot more sense. And ultimately, being able to use piping in this way, you will see a lot of tutorials online that use that. And indeed, base R, so I haven't talked about this a ton, but tidyverse is, again, a set of packages that extend the core functionality of the R language. There are a number of functions available in the core functionality of the R language. And recently, within the past several months, an actual native pipe operator has been added to ours. So this was something where previously you had to use the Magrider package, which loads with the specifically with dplyr to use it, but now piping is very much native to R. And so the result we get back then is a data set that has a new percent column calculated, and then we've gotten rid of all of those other columns that we don't need. So in this particular case, we'll run that, we'll take a peek on the R side, and you'll see here. So for Apache County, what we basically done is we said 3,800 people identified as Hispanic in 2020 out of 66,000. What's that percentage? Well, we said divide value by summary value and then multiply by 100. That's 5.85%. So we've been able to use tidyverse tools to do that calculation for all of the rows, and in this case, for all of the racial and ethnic groups by county. We then can start doing some analytics on that data that we've created. And one common way that tidyverse tools are used are for group-wise census data analysis. So what the tidyverse implements is what's called the split, apply, combine method of data analysis, which is extraordinarily powerful and relatively intuitive. You know, the idea is that you identify salient or meaningful groups in your data. You then split the data set into those groups. You apply a function to each of the groups. And then once that function is applied to each of those groups, such as calculating a mean or finding the maximum, you take that result and you combine it back into an output data set that will allow you to compare a metric across groups. And so this is implemented in the tidyverse using the group_by and the summarize functions. And the default tidy format returned by Tidycensus works great with this workflow. So let's ask a few questions and explore our data. Let's say, which group has the largest population share by county? What we can do here is specify, again, using our piping operator, we can say, create a new object called largest group. And so we're talking about the largest population share. That takes our AZ race percent object, then groups it by the county name, then filters the data where the percent column is equal to the maximum percentage value by county. And when we do that, our output gives us back all 15 counties. Again, Arizona has 15 counties, Texas, we have 254. So theirs is a little bit easier to make comparisons. And we can see here that 2 counties, Santa Cruz and Yuma, have, in this case, a majority Hispanic population. Most counties in Arizona, the largest group is non-Hispanic white. And we have 2 counties where the largest group is Native American, Apache, and Navajo counties. And we can run that over on the R side by running this block of code, and we'll get the same result. So what we're doing is we're stepping through an entire process where we're taking the census data that comes in from Tidycensus, and then we're applying some of these data analysis functions to start to generate new metrics and then analyze those metrics. Another thing that we can do is use the summarize function here, where we take all of the values, say, in a group. In this case, we're grouping by a different variable, which is the variable column, where we're saying by racial or ethnic group, what is the median percentage value across counties in Arizona? And so what that gives us back here is for counties in Arizona, the median white value is 53%. The median Hispanic value is 28.6%. The median Native American value is 2.8%, et cetera, et cetera. And so we can run this through, and you get the result. So the last piece here that I want to show you for this section is a question that people are very commonly interested in when working with 2020 data, asking how areas have changed since 2010. And so this is something that the tidyverse really helps us out with a couple important caveats that I'm going to cover in just a moment. We don't have information yet on a detailed race, ethnicity, or kind of detailed age and sex breakdowns. So we can't make those comparisons yet, but we can make some comparisons between, say, total population, total households, and some of the other metrics. And so we might be interested in understanding, say, how data by a given geography changes over time. Which areas in the US have experienced the most population growth, which have experienced the steepest declines. So Tidycensus gives access to the 2000 and 2010 decennial census data. One important caveat, variable IDs are not necessarily consistent across decennial census data sets. They're certainly not going to be consistent between 2010 and 2020. So you kind of have to go through the same process of looking up your variables for those data sets and then making sure you find a comparable data set. And the variables can change a little bit too. So it's not always going to be a 100% apples to apples comparison, but for total population, we can at least get pretty close. If you want to look up data for 2010, you're going to change the year argument to 2010 and then specify an appropriate variable. So what I'm doing here is I'm pulling in data using Get Decennial again for all counties in the United States for the appropriate total population variable, which its ID is P001001. As a reminder here, the load variables function can be used for other data sets. For example, if I want to look at variables in 2010, I'm going to make an object called vars10. I'm going to type in load underscore variables 2010 for the year. And then my data set is going to be SF1, which represents the summary file 1 for 2010. I pull that down. I then can view it. And these are going to be all of my variables in summary file 1 for 2010. And you'll notice our H values, those are going to be households. And then our values that start with P are going to be people. And so you might need to spend some time browsing through this. This has about 9,000 variables instead of the 300 currently available for 2020. So again, this is part of that research process where you're identifying what you want to focus on. In this case, we're going to bypass that here. I'm giving you the value for total population, and we can pull that down and take a look at county population by in 2010. And as we can see here, we have counties in 2010 with population values. What I want to do is ultimately compare 2020 population to 2010 population. And I need to follow a couple steps to do that. You'll notice here that my 2010 data are returned in the exact same structure as the 2020 data. And so what I'm going to need to do is two things. First, I need to identify a way to combine data from 2010 with data from 2020. I'm going to use the GeoID column for that. And for those of you who say come from a database background or say a GIS background, you'll be familiar with the concept of joining tables. And we join tables based on common values in a key field. We're using GeoID as the key field here, and we're going to be matching those values in the 2010 data set from a data set we'll acquire for 2020. The tricky thing is all the variable names will be the same. So we need to make some modifications so we know which is which. And so what I'm going to do is go back to the handy select function. And an extra bonus of the select function is that while you're selecting, you can actually rename your columns in the process. So what I'm doing is creating an object here called county population 10 clean that is derived from my population 10 data set, where I take that data set, then I select the GeoID column and the value column as value 10. So if I say value 10 equals value, you can read that as select the value column, but rename it value 10. And I get back this particular object where I have GeoID and value 10. So I now know for each GeoID what the value was in 2010. So I'm going to go ahead and run that through. In the next step, I need to grab the same data for 2020. And you'll notice I go through the same process. I use the appropriate variable for total population for all counties in the US for 2020. I'm going to keep the GeoID column. I'm going to keep the name column as well, so I know what the name of the county is. And I'm going to do the same renaming process, but I'm, in this case, going to say value 20 equals value. I then use the left join function. And the kind of join family of functions in dplyr allow for implementation of the typical types of database joins that you might need to use. So you can do left joins where all rows on the left-hand side of the join are retained. You can do right joins where all rows on the right-hand side of the join are retained. You can do inner joins where only matching rows are retained. You can do outer joins where all rows are retained. In this particular case, we're retaining all rows in 2020, and we're joining to it rows from 2010 based on common values in the GeoID column. And so when we do that, we get back a data set that looks like this, where you have counties with a name, a value in 2020, and then a value in 2010. And you can see here, for example, Black Hawk County, Iowa, barely changed at all between 2010 and 2020. Some of these other counties, you might see modest declines, modest growth, but that's going to vary county to county. We have over 3,200 counties that we're working with. In the next step, and I'll do this all together in a little bit, we already learned how to calculate new columns. And I can use the mutate function to do that and assess change over time. So I'm going to create two columns here. One will be the total change, which is my value in 2020 minus my value in 2010. And then the other is going to be percent change, where I take the total change divided by, that I just created, the total change divided by the value in 2010, I multiply that by 100, and that gives me percent growth or percent decline. And the result then that I get is showing, in this case, Black Hawk County gained 54 people for a very small 0.04% growth. We can see in alternative sense, there are some places like Adams County that actually lost 325 people, which was an 8% decline, which for a small county like Adams County was actually pretty big. And so I can jump over to R, and I'm going to run through all of that code. And it just calculates in moments for me. And as a reminder, if you want to browse this information, you can view the county change object. And if you want, you can actually sort this data table. So if I wanted to see which county gained the most people, I can click Harris County, Texas. So shout out to Texas. My county, Tarrant County, came in 5th. We added over 300,000 people, but Harris County added more people than any county in the US during the 2010s. The county that lost the most people was San Juan in Puerto Rico. That makes sense. Baltimore City, which is treated as a county equivalent, lost 35,000 people. The US county that lost the most people was Wayne County, so Detroit, losing 27,000 people. A caveat, a major caveat, we'll be covering in great detail in the third workshop, but you want to be aware of it now. Geographies can change from year to year. This can create issues in time series analysis. It always comes up when working with time series data. And so just something to be aware of. For example, if I use this command where I'm checking with the is.na function to see where I have NAs, which mean missing data, meaning that my join didn't match for 2010 and 2020, there are actually 4 counties or county equivalents that don't match between 2010 and 2020. Let's jump over to R and try that out. We have the Copper River census area, the Kusovak census area, and the Chugach census area in Alaska, and Oglala Lakota County in South Dakota that did not match between 2020 and 2010. Why is this? Well, sometimes counties or census enumeration areas are redrawn. This is a common thing in Alaska. You'll rarely have the same census areas in Alaska from census to census. So that's something to be aware of. And Oglala Lakota County in South Dakota is an interesting case because it actually was renamed between 2010 and 2020. It used to be called Shannon County, and it was renamed Oglala Lakota County. When a county gets a new name, the Census Bureau gives it a new GeoID. And that means that even though Shannon County and Oglala Lakota County are the same, they actually don't match between the two censuses. And so as an analyst, you would need to account for that. For counties, again, we only had 4 that didn't match. So it overall is a minor issue. What we'll be talking about in 2 weeks when we talk about the new ACS data for small geographies like census tracts and block groups, the Census Bureau redraws census tracts, block groups, and blocks with every decennial census. And so census tracts in 2020 are going to be different, in some cases totally different than census tracts in 2010, requiring special methods to deal with that. And we'll talk about that more in a couple of weeks, but that's just something to be mindful of. You can't do this process for census tracts between 2020 and 2010 because it just won't work because they've been redrawn. It's a totally different set of tracts. So you'll need special methods for that, which we'll cover in 2 weeks. All right, so that concludes hour 2 of the workshop. I've got some exercises for you to take a look at. Take that county change object that we just created. And I showed you how to sort your data. That's sort of the quick and easy way to do it. Try using tidyverse tools to sort your data. You'll remember the arrange function. Try using tidyverse tools to answer these questions. Which counties gained and lost the most people during the 2010s? And then work on that percent column. So how many counties in the US grew by 40% or more? How many counties in the US lost 20% or more of their populations during the 2010s? So try answering those questions using tidyverse tools. So we'll take about a 10-minute break, collect some questions. Please keep asking in the Q&A. And we'll come back in about 10 minutes, maybe go over those questions briefly and move into the final hour of the workshop, which focuses on data visualization.
All right, everyone, we'll see you at 8 after the hour. We'll restart in about 30 seconds. So if you're finishing up anything, please try to finish up in the next 30 to 60 seconds. All right, we had a few questions come in, some before the break that we wanted to respond to. One collection of questions, Kyle asks about the data that are available through Tidycensus. So we have one question about whether Tidycensus can access the population estimates program data. And there's another question that's related that asks about components of change, whether births and deaths data are available.
Yes, great question. And they're actually both have the same answer. So births and deaths data are found in the population estimates program. And the population estimates program is kind of a separate set of estimates produced by the Census Bureau that is sort of done in parallel to the ACS. It's different from the ACS, and it's used to basically do population projections. And so what the Census Bureau releases typically year to year is the population estimates, which are basically you take the decennial US Census as a base, and then you carry that forward in the intercensual years to the next census. And they break that out, and you can usually get down to the county level into components of change estimates. So you can get births and deaths, you can get migration, you can get rates of each. And Tidycensus implements that in the get estimates function. And so just to show you briefly, and I'll probably continue to refer back to this, but there are two places that you want to look to get more information about Tidycensus. One is going to be the Tidycensus documentation, and one is going to be my book. And so my book is linked way back here at the beginning of the slides. Like way back. So if you follow that link, you'll find my book. This is Analyzing US Census Data. You'll notice a lot of the examples we're talking about today are expanded upon or sort of replicated in chapters in the book. If you go to chapter 2 in the book, and then you click on the right-hand side to other Census Bureau data sets in Tidycensus, you can learn how to use the get estimates function. And so the get estimates function allows you to get components of change estimates. And there's even more information about this in the Tidycensus documentation as well. So here's how you pull down components of change estimates for 2019 in Queens County, New York. And you get all sorts of information on births and deaths, and also the crude birth and the crude death rate, in addition to some information on migration. So there's some more information on how to use that and get started with it. One small caveat. So Tidycensus, there's been a modest release of population estimates for 2020 and 2021, but Census postponed the 2020 estimates and then released them in bulk with the 2021 estimates, but we don't have components of change yet for 2020 or 2021. So that stops right now at 2019. I anticipate we will get them at some point, but Tidycensus doesn't yet support those new estimates. I'm working on integrating that, but that's still something that isn't fully functional yet. So we don't have, say, birth rate for 2021 yet. We will in the future, but you can get that all the way up to 2019.
Great, thanks. So we have another question. We had a couple questions about weights that I answered in a little hastily, and and left off a lot of nuance. But there was a question about what weights are being used with the decennial census, and whether there are weights. And I wondered if you could add a little bit of the nuance that I left out.
Yeah, so a couple of things to talk about. I'm just kind of moving back here to part 3. So great question. There are a number of different types of data sets that you'll encounter when you're working with census data. So the decennial census data are kind of complete count enumerations or aggregations that you're getting here. And so there are no weights involved that you'll work with. Those are going to be just the tabulated counts, and those subject to differential privacy, and we don't have a metric to assess the level of errors introduced in any particular value you get back from the 2020 census. So that is a caveat, but there aren't any weights to use. Those are already kind of aggregated counts for those categories. When you're working with American Community Survey data, which I'll be covering in 2 weeks, those are survey based on survey samples. So what you'll get back are estimates characterized by a margin of error. Weights under the hood were used by the Census Bureau to produce those estimates. If you're pulling ACS data, you don't need to use weights because the weights have already been baked in to those estimates. Where you would use weights is if you're dealing with individual level microdata. And you can get microdata for the ACS in Tidycensus with the get PUMS function, which accesses the public use microdata series microdata. I'm not covering that in this workshop series, but Tidycensus has built-in functionality to download microdata and also handle sampling weights. If you go back to my book, Chapter 9 tells you all about how to grab microdata. And then Chapter 10 tells you all about how to handle the weights that are associated with the microdata samples. So that's not something we're covering in this workshop series, but if you want to learn more and create your own custom American Community Survey estimates, read chapters 9 and 10 of my book because they cover that in detail.
And just to follow up with one more thing, you mentioned, I think early on that that there's some question of whether the 2020 census would have a PUMS release. Would that have microdata on it as well? Or sorry, would that have? Sorry, would the microdata for the decennial census potentially have weights as well?
So it would. What I've been reading, and this is part of the general conversation around differential privacy, I don't believe there will be a 2020 census microdata file. I have not seen any suggestions that will be released. The ACS microdata program is ongoing for now, but I haven't seen anything about a decennial census microdata file. So I wouldn't necessarily expect to see that. I might be wrong, but I don't believe that is currently planned.
Okay, but for those who are looking back maybe at the 2010 census, the 2010 and 2000 census PUMS, you may see weights on those microdata respondent level files.
Yes, you
so I just
would.
wanted to point out that what I said in some of my responses was not entirely accurate, that there are occasions with the microdata where you may see weights for the decennial census.
Yeah, that's right.
All right, well, looking forward to the final hour of the workshop, and
all right,
I'll hand things back over to you then.
Great, let's jump right back in, and we're going to be covering visualizing census data. So we've learned how to acquire data, we've learned how to explore data and start to analyze it. Now let's think about how we can create some graphics. And with respect to data visualization, there are a couple different sort of families of data visualization that are you'll typically think about when you're doing data analysis. One is exploratory visualization, in which the audience is typically you. You're creating data graphics to try to learn some insights about your data, but you're not necessarily creating it with the intention of showing it to other people. And the other aspect of it, or the other side of it, is going to be explanatory visualization. We're creating data graphics that are actually used for presentation and used to show someone something or communicate something to someone else. And you can produce both types of graphics pretty readily with ggplot2, which is the core framework for data visualization in the Tidyverse. And you can create all sorts of amazing stuff with ggplot2 and its extensions. I'm going to show you a few kind of fun examples of this over the course of this last hour of the workshop, but there's a whole lot more that you can do with it. And so for starters, I'm going to pull down some data for exploratory analysis using some of the methods that we have learned. So I'm going to create a new data set called GA Hispanic. And it's going to be data on the Hispanic population in Georgia by county. We're going to return it in wide format and then calculate a new percent column. That is 100 times the Hispanic column divided by the total column. So you'll notice a lot of the tricks that we've learned in this workshop to this point, where we're automatically renaming columns, we're getting data in wide form, we're using mutate to calculate a new column. That's all sort of baked in. And as you get better and better at working with Tidycensus and working with the Tidyverse, you'll notice how you can put these different pieces together and create pipelines for data analysis and data acquisition. And it becomes really, really seamless once you get the hang of it. So let's go ahead and pull that in and take a quick look at our data. Excellent. So here's our data set that we're working with. We want to do some exploratory visualization on it. We have our GeoID, we have our name, we have a total column, that's going to be our total population. We have our Hispanic column, that is our Hispanic identified population. And then we have a percent column. So the percent of the population identifying as Hispanic. So with respect to visualization, ggplot2 sets up really well for exploratory visualization. And some of you may already be familiar with ggplot2. What we're going to do is start from the ground up and then work our way into some more advanced features. So hopefully there'll be a little something for everyone, whether you have never used ggplot2 before or whether you're an experienced user. So when we're preparing graphics in ggplot2, we initialize a graphic with the ggplot function. That basically creates an empty template on which you can layer on various plot elements. So what ggplot typically takes as arguments are the name of a data set. In this case, it's going to be our Georgia Hispanic data set. And then an aesthetic mapping specified with the AES function. And your aesthetic mapping is where you take values in columns and you map those values to different elements of the chart. So typically you'll map elements to an axis. So the x-axis is used here. We're mapping the percent column to the x-axis. You can also map elements to the y-axis. You can map elements to other, or you can map columns to other elements of the chart, such as the fill of the bars, the outline of the bars, the size of dots, really all sorts of different things that you can do. And so once you've specified the general structure of the chart, you then link layers. You basically layer on chart components. You tell ggplot2 what to draw based on the data set and the aesthetic mapping that you've specified. So in this particular case, we say, set up a ggplot object from the Georgia Hispanic data set with an aesthetic mapping of percent on the x-axis. Now, we're going to use one of ggplot2's many geom functions. And a geom in ggplot2 is short for a geometric object. You can think of as shapes, so to speak, that you'll use to represent your data. And what we'll do here is use a very common exploratory chart type called a histogram, in which the frequency distribution of a data set can be visualized with binned bars. So your overall distribution of values is divided up into bins, and then we count up the number of values in each bin, and each bar is then drawn relative to the number of values that fall within that bin. So I'm going to say geom underscore histogram with 10 bins to draw a histogram, and I can modify this bins argument if I want to. All right, so let's try this out. Let's make a chart. If I run this code, I get a chart in my screen. And one thing that's great about RStudio is you have this plots pane. And the plots pane has a variety of different features that are really, really handy. So our plot shows by default, we see here that basically what looks like kind of the median value is around maybe 5 or so percent. In Georgia, 4% Hispanic among counties in the state. You have kind of a longer tail here of counties with a relatively large Hispanic population, but the bulk of counties have a pretty small Hispanic population. One thing that's really cool about RStudio is that, and ggplot2, is that by default, ggplot2 returns what are called scalable plots as scalable vector graphics, or SVG. And what that means is you can actually adjust the size of this plots window, and it will auto adjust the size of the plot for you. So that's something that I have always really appreciated about working with R and RStudio. If, for example, my plot was too scrunched, I can just expand the plot window upward, and I can see my chart in much more detail. And this will come in handy for some other examples that we'll explore later in this section. I can click the zoom button, and that's going to pop out a larger version of the plot in a different window. I can click the export button. I could save as an image. I could save as a PDF. I could copy it to my clipboard if I want to just copy paste into a tweet or into a Word document. There's a lot that I can do. So that little plots pane in RStudio is very, very handy. One of the great things about ggplot2 is you can set up a consistent syntax and then iterate through different geoms to really pick the exploratory graphic that you like the best. So one method of showing univariate data distributions is a histogram. Another common method is the box and whisker plot, where implemented here in geom box plot, you have a box that represents in a central axis the median. So our median looks like it's about a little over 5, and the interquartile range, so the 25% to the 75% mark. We then have whiskers, and then the dots beyond the whiskers are going to be your outliers. And so box plots are one method of doing exploratory visualization of a single data distribution. We also have geom density for kernel density plot, so a smooth representation of the frequency distribution. Geom violin for a violin plot, which is sort of a hybrid density and box plot. And to swap those out, all you have to do is just use a different visualization method. You don't have to reconfigure all of your code. You say, I have an aesthetic mapping that is mapping percent to the x-axis. I can use geom histogram for a histogram. I can use geom box plot for a box plot. I just swap that out. And you'll notice here, this code is very, very similar to this code. And I can run it and I get myself a box plot just like that. And so these are what we call exploratory graphics, where I can see oh, my data distribution is very much right skewed. I have the bulk of my values over here that tends to be pretty low, but this long tail reaching to the right. And I wouldn't necessarily present this to someone else or publish it in a paper or something like that. That's not necessarily something I would do. I would want to polish it up first. But for understanding the distribution of values in my data, this type of exploratory graphic, where the primary audience is myself, is really, really useful. And ggplot2 sets up very well to create that. So those are examples of univariate data visualization. In other cases, you're going to want to create multivariate graphics where you have, say, 2 numeric columns in your data set, and you want to look at, say, the joint data distribution. And so in this particular case, we might be interested in here is taking a look at how percentage Hispanic varies with the size of the county. So kind of asking the question, do larger counties tend to have proportionally larger Hispanic populations, or do smaller counties tend to have proportionally larger Hispanic populations? And so it's kind of asking, like, is the Hispanic population maybe more rural, so kind of larger in smaller counties, or is it more urban, maybe larger in larger counties? And so we can accomplish that with a scatter plot. And so in this particular case, geom point is going to be the geom that we'll use to draw dots and implement a scatter plot. And you'll notice that we changed the aesthetic to map a column to the x-axis and a column now to the y-axis. So we're mapping percentage to the y-axis and then total population to the x-axis. And so let's go ahead and try that out. I'm using this special option here to disable scientific notation on the plots, which R draws by default, just so we can see the raw numbers. And here I have my scatter plot that shows potential relationship. Now, it's not entirely clear. You can definitely see that you have a few of these really big counties that probably have above average Hispanic populations, but you also have some small counties with large Hispanic populations too. So, what is the underlying relationship? Again, in an exploratory sense, we're just kind of trying to understand that general correlation. We're certainly not getting into any kind of causality or predictive analytics or anything like that here. And so what we're trying to do is just understand in an exploratory sense how these data distributions might covary. And so a couple methods to try to clarify in greater detail what this relationship might be. We can add a smoother or regression line superimposed with an extra geom. So one thing that's great about ggplot2 is you can layer on additional geoms if you want to superimpose one geom over another. And so in this particular case, each geom picks up the same aesthetic specified in ggplot, but they just draw different graphical elements on the chart depending on what the specific function implements. So this is basically saying, make a plot of the Georgia Hispanic data with total population mapped to the x-axis and percentage mapped to the y-axis. Draw points representing that, and then draw using the geom smooth function, draw me a line using method equals LM draws basically a linear regression line using the geom smooth function. And so I can do that. And I show kind of a modest positive correlation between the two columns. Now, this is, again, exploratory. You might be asking questions about, well, is that relationship truly linear? Is it appropriate to consider it in sort of using method equals LM? This is the type of iterative process that visualization helps us with. And another issue as we know from looking at our univariate plots, it's a heavily right skewed distribution where you have most of the counties, you can see it here, way down here with very small populations. Then you have a few counties in Georgia with populations nearing 1 million people. So the problem is using a linear x-axis here, it makes it very difficult to see any sorts of relationships that might be salient among the small counties, because the plot has to adjust for the size of the large counties. And so typically, if we have a data distribution like this, we might consider maybe transforming the data or transforming the axis. And that's something that ggplot2 can do with this function here, scale x log 10. So what we're doing is, instead of using a linear scale to plot the x-axis, we use a logarithmic scale in which each tick basically is an exponential increase rather than a linear increase. And we can also draw a smooth curve with the default Geom smooth to look at the relationship. So we see it kind of goes up and then down and then up again with an increase in total. Now, again, in interpreting this plot, you do need to kind of think through what this means. But at the end of the day, this allows for showing us that greater spread and making comparisons between dots that otherwise would have been really clustered way down here, but may actually be reasonably different from one another. And we can really suss out that relationship a little bit more. So when I run that code, I get this plot with the x-axis on a logarithmic scale, which much more evenly distributes my dots along the x-axis through the plot. So these are sort of the little things when you're exploring a data set that you might consider doing. And we're not getting to the point of presentation yet, but if you're trying to understand an underlying relationship, visualization helps you see things in a particular way. But you might want to create a bunch of different plots like this to get different views on your data. And ggplot2, with minor modifications to the code, helps you really iterate on this and generate multiple exploratory graphics. So we talked about, to this point, is exploratory visualization. Now let's start moving more into the subject of explanatory visualization. We're actually thinking about creating graphics that you might want to show to someone else. And that's where you're going to want to not only represent your data in a coherent way, but also clean up the styling so that you can maximize the effectiveness of your graphic as a communication tool. And ggplot2 is fantastic for this. So let's go ahead and set up a prompt and do a little data setup. So we're going to be looking at, by county, household vacancies in New Jersey. So very similar code to what we used for the Georgia data, but we're grabbing different variables. So total households and vacant households. And then we're going to create a new column called percent vacant. That is the percentage of households in the county that was vacant when the census was enumerated. And so let's go ahead and pull down that data and we can take a quick look at it. And so we have here counties in New Jersey, total households, vacant households, and then a percentage. We notice that there's quite the range. So Cape May County, nearly 60% vacant. Cape May County is kind of resort beach community where a lot of people might have second homes, vacation rentals, and that's being reflected there. Atlantic County with that high values is also, figures prominently in that respect. And then more residential counties are going to typically have vacant housing values below 10%. So to visualize categorical data, we're going to turn to some different methods. And so to this point, we've only been focusing on visualizing numeric data, either in a univariate sense or a multivariate sense. if we want to visualize two columns, but where one is numeric, such as percent vacant, and the other is categorical, which in this case is going to be the county name, so we can compare across counties, we're going to set up the plot in a very similar way. So we're going to initialize the ggplot object with the name of the data set. We'll specify an aesthetic mapping where x equals percent vacant. In this case, we're mapping a categorical column, so the name, to the y-axis. The geom call function will draw a bar chart for us. And so your bar chart is going to look like this. Let's run that through. All right, here we have a bar chart. It is a start, but it has some pretty clear problems. And so an exercise that I do when I'm teaching visualization at TCU is I'll make a chart like this. And I'll basically say to my students, tell me what is wrong with it and how you can improve it. And there are a few things about this that the default view doesn't do a great job of. So first and foremost, there's a lot of redundancy on the plot. We see here that the name column occupies up a ton of space, and we really want to be focusing on these bars. And in part, it's occupying a ton of space because we have repeated text over and over. County, New Jersey, County, New Jersey, County, New Jersey, County, New Jersey. We don't need that information, so we might want to get rid of that. Another thing about it is the data aren't sorted. And so we can clearly see that Cape May by far has the largest value, but how do these other counties compare with one another? An intuitive bar chart would allow us to make those comparisons, but because the data aren't sorted, it's very difficult to tell. So Morris County and Middlesex County and Bergen County appear to be about the same, but I couldn't tell you from looking at it which one is higher and which one is lower. So we want to make a couple of changes, and this is where we start to get into some more advanced functionality of ggplot2. We're going to draw the same graphic, but make a couple of changes. I'm going to specify in my aesthetic mapping, not that the y-axis is going to be the name, but I want the y-axis to be the name reordered in order of percentage vacant using the reorder function. This is really, really handy because it will sort your data internally and return a sorted plot. I use geom call again for the bar chart, and now I specify a number of styling functions. Scale X continuous allows me to modify continuous access. And I'm using a label function called label percent from the scales package. I set the scale to 1, meaning that the scaling factor that I'm multiplying each value by is 1, because my data are already percentages. What this is going to do is it's going to attach a percentage sign to each of the x-axis tick labels, so communicating that it's in fact a percentage. I use scale Y discrete, which is used for categorical axes, and I use some special new code that is a little bit more advanced, where I specify a custom labeling function. And we're not going to get into the weeds of kind of learning about writing your own functions in this workshop. That's a touch more advanced. But what this is meant to show you is that you can label your axes in any custom way that you want. What this is doing to translate, if you're less familiar with R, it's saying that for every y-axis tick label, which we're going to call Y, use the str remove function, which is a function in the stringer package that loads with the tidyverse, to take that text and get rid of space county, comma, space New Jersey. Because as we saw on the plot, that is common to every county here. So basically what it's going to do is internally, for each of these y-axis tick labels, it's going to get rid of it for us. I then use the labs function to label different chart elements. I want the x-axis title to be percent vacant households. I don't need a y-axis title because we already know that those are counties. I could put something in there if I wanted to, but I'm going to explain that in the title, household vacancies by county in New Jersey. And then I specify a subtitle 2020 Decennial US Census. Let's try running that and watch how the plot changes. So here is our default plot. This is much, much better. We have sorted data in descending order of household vacancies. I can now make comparisons much more readily between, say, Middlesex, Somerset, Morris, Bergen counties, because those data are already ranked. I have an intuitive access label. I put a little percentage sign on the ticks. And importantly, I've removed County New Jersey from the y-axis. So I've done a lot of cleanup to make this much more intuitive. And I'd be comfortable sharing this with someone now. I wouldn't share the first one, but I'd be comfortable sharing this one. You might want to do more styling, however, which makes a lot of sense. And ggplot2 allows for near infinite customization. You can't do absolutely everything. For example, dual y-axes, ggplot2 does not accommodate that, but you can style charts to your heart's content. And I want to show you a few examples of how you can do that. So inside of geom_call, we've been using that without arguments, but you can actually put in specific aesthetic mappings that are going to apply to all elements. So if they're wrapped inside of AES, the aesthetic mappings will be relative to each data value. But if they're specified here outside of AES, in this case, corresponding to this bar drawing function, I can say, make the fill navy, make the color navy, set the alpha, so the transparency to 0.5. So I'm going to have a solid navy border for my bars, and then a semi-transparent filled in bar. I can specify a theme. There are a lot of built-in themes in ggplot2. Theme gray is the default. My favorite is theme minimal, and it's a minimal white theme that kind of mutes some of the ancillary chart elements and really brings your data to the forefront. I can specify a base font family. I've chosen here Verdana because that tends to be available across operating systems, so it should work for you. But if you have Google fonts installed, you can use Google fonts. If you have special fonts on your operating system that you really like, you can use those fonts as well. So just by making those modifications, I'm going to run this and take a look at how my plot changes. Now I have a different style. I have solid borders, semi-transparent background, semi-transparent bars across a white background. I've changed the font to Verdana so it has slightly different look. Really, if you like this plot better than this one, that's a really matter of personal preference, but hopefully that illustrates that you can really customize the appearance of your charts to your liking. And there is a lot more that you can do with this. So in the last kind of series of examples, I want to show you some more advanced census visualizations using ggplot2. So, these are potentially, I think they're going to be interesting to everyone. Hopefully things make sense, but if you're new to ggplot2, just follow along and kind of try to get a sense of how things work. If you've been using ggplot2 for a while, maybe there's some new things that you'll get out of this. So we've talked about group-wise data analysis in hour 2. We can also talk about group-wise data visualization. And ggplot2 sets up really, really well for this. An interesting question that we're going to explore here, and this is our prompt, is we're going to look at the census tract level in New York City, and we're going to ask, how does the percentage Black population by census tract, non-Hispanic Black, vary among the 5 boroughs of New York City? So you'll notice here a couple of things that we're doing. This is very similar code to what we've used before, but we're going to be grabbing a variable here, and we're going to be grabbing a summary variable, so slightly different structure, just so we get comfortable with the different ways that you can request data. You'll notice I'm specifying 5 different counties. You can get multiple counties at a time if you want to. Now, something to be aware of, you can't go in and say, I want Queens County, New York, and Tarrant County, Texas, and Los Angeles County, California, all in a single call. That's not something, given the structure of the API, that Tidycensus sets up for, but you can request multiple counties at a time within a state, or you can just request all counties in the US at a time and filter down. So what I'm doing here is I'm actually going to run this code, and we're going to take a peek at it. We're pulling down track data for those 5 counties. And we get it near instantaneously. And we've pulled down data for those 5 counties where we have a value and a summary value. And then from that, we can calculate a percent. So this reflects percent non-Hispanic Black by census tract in all of the 5 boroughs of NYC. And this loops back, interestingly enough, this question, if we want to compare the data distributions by county, how do we do that? There isn't a column that identifies the county. But as we learned in the Q&A after hour 1, you have county information in 2 places. One is digits 3 through 5 of your GeoID. And the second place is in the name column. So you can extract this information intuitively from either the GeoID column, doing basically string extraction, where you pluck out using the str sub function in string R. If you're interested in doing that, you can pluck out digits 3 through 5 from your GeoID. Or we can create new columns from this name column. The separate function in the tidyverse is great for this. So we noticed before that our name column, so I'm going to do NYC % Black from the name column. Let's pluck out the first element. We have a census tract name, comma, a county name, comma, state name. What I can do using the separate function is I can specify that I take that name column and it will separate it into multiple columns at a delimiter. In this case, my delimiter, which is passed to this sep argument, is comma space. So it's going to break up the text in the name column into 3 different columns, and the dividing point is going to be wherever it finds a comma space. To show you what this looks like, I run it, and now I have new columns: tract, county, and state. My name column is now 3 separate columns. Now I can use this new information to use the county column as a group, and I could do group-wise analytics on it, like we learned in hour 2, or I could use this for group-wise visualization. So let's try this. There are a couple different ways that you can do group-wise visualization in ggplot2. One is to specify your group as an aesthetic mapping. For example, I'm drawing here a density plot to show a data distribution. I could specify in my aesthetic mapping fill equals county. If I do that, what ggplot2 will do is draw a separate density curve for each county on the plot. If we try this out, you'll notice here that I have now 5 curves. We see here that there are 3 counties where the bulk of census tracts have relatively small Black populations, and that's going to be New York, Queens, and Richmond County, which is Staten Island. You can see here that Kings County, which is Brooklyn, is the county that has the census tracts with kind of 75% Black and up. But Bronx County has a preponderance of tracts that are around sort of 15 to 30% Black, which is more in that sort of area than any of the other boroughs. This is interesting. I like these plots, but they can get kind of noisy because all of your curves are overlapping one another. And so something that you might consider doing instead is creating something called a small multiples or faceted visualization, where you identify the groups in the data set and then you draw a separate plot for each group. ggplot2 sets up great for this. You basically use the same ggplot code, but you add one line here called facet_wrap. And you use this the tilde here, which is formula notation in R. It basically says, facet my plot by unique values in the county column. Make me a separate chart per county and then tessellate it on a chart. I then specify some styling here. And when I run this code, let's try it out. I now have 5 separate plots per county with some intuitive styling, allowing for comparisons of the different data distributions. So an alternative to the density plot is a ridgeline plot, which is pretty cool. It's implemented in the GG Ridges package. And what that does is it does overlapping density plots, but that are staggered. So you can kind of see a profile, so to speak, of different density plots. And it's implemented in a pretty intuitive way. Instead of using geom density, you use geom density ridges. You'll map a categorical column to the y-axis instead of, say, the fill or as a faceting column. I'm using theme ridges here, which is going to have a whole lot of underlying formatting that makes ridgeline plots look really, really good. And when I use the ridgeline plot, just think about, you have, for example, this plot, which is a faceted density plot. A ridgeline plot is sort of a staggered density plot. And you can see overlapping distributions here, which are pretty interesting for making comparisons. These types of charts are really, really popular. So we're getting almost to the end here. The last example, and this is the most advanced example that I want to show to give you a sense of where you can go. And we've talked about a variety of methods for visualization and for data acquisition and data wrangling. And hopefully you have a good sense by now of what is possible with respect to Tidycensus. And the last example is really thinking about, once you start to get the hang of R and once you start to get the hang of all these tools, where you can go from there. And so this is the most advanced example. And I'm not going to get too much into the weeds with respect to the code, but really to show you there are all sorts of different extensions to ggplot2 that you can use. And we're going to be working in particular with the geofacet package, which allows you to create geofaceted plots, where the facets represent a relative geographical location of the underlying data. What we're going to do here is create geofaceted histograms. So a separate histogram of the percentage white population by state in a tile grid map. The first bit of code is really interesting. I'll get this question often. How do I get all census tracts in the United States or all block groups? Well, you can't get that by default from the Census API, but what you can do is you can use R, and this is where the power of R really shines. You can iterate through every state, grab data for those states, combine it, assemble it, and clean it up. So this is using some more advanced code kind of beyond what we're really covering in the workshop today from the per package using the map_DFR iterator. And what you can read this as is what this function does is it says for every value in this vector where you're combining all the state abbreviations, which is built into R in this object state.ab with DC. So for every state, grab tract level data, calculate the percentage non-Hispanic white, and then separate out its name column. And to show you how that works, I can run it and let it fly. And it takes a few moments to iterate through, but because I am using this iterator, instead of having to go state by state, I'm telling R, just go grab all the states for me. And ultimately, kind of, especially if you're just starting to learn, this is going to be a little bit more advanced, but hopefully it's a preview of where you can get to when, along your R learning journey. So you'll notice it just takes a few moments to do this. It's stepping through every single state. It's grabbing all this. It's grabbing all the data. It's calculating percentage non-Hispanic white along the way. And then once it gets through every state, and really this is taking only about a minute to acquire, I now have a data set that has all 84,414 census tracts in the United States with the data that I've asked for. So instead of having to lumber through and combine data sets, I have been able to, in about a minute, pull down an 84,000 row strong data set for all census tracts in the US. The geofacet package is really cool. The facet geo function, what it does is it uses a built-in grid to make a faceted plot relative to the location of the state. And so I'm just going to run this through because we're almost out of time and show you how it works, because this is a more advanced visualization. And you can make really cool graphics like this. So instead of the facets being, say, in alphabetical order, each little histogram is relative to the location that it actually is, say, on a typical plot of the US. And so you can interpret these histograms. The y-axes are unique to each state. You have some states like New York where there are a number of tracts with very low white populations, a number of tracts with very high white populations, not as many in the middle. States like Maine and Vermont, New Hampshire, most tracts have mostly white populations. California is pretty different, where you actually have a lot of tracts with pretty low white populations and very few that are homogeneously white. And so this is sort of a fun example of where you can go along your learning process. But the whole goal of Tidycensus, when I was developing it, is this is the stuff that's fun, creating these data graphics where you can really learn stuff from it and present interesting findings to others. Let's make the data wrangling process, the data acquisition process, straightforward. And let's take that laborious and sort of tedious process out of it. And let's get the analyst faster to really making cool stuff. And that's what I've hoped to accomplish with this software. And hopefully you have some ideas of where you could take this on your own as well. So that's what I have. Thank you so much, SS Dan, Bill, JP, for hosting. Thanks to all of you. Looks like about 60 of you stuck around for the 3 hours. So credit to you. I really appreciate that. In a week and 1 day, so next Friday, all about mapping census data in R. Your cartographic questions will be answered. So JP, if you have any concluding thoughts, I'll hand it back to you.
Kyle, thank you so much. Thank you. This was just a phenomenal presentation today, and I think we all learned a lot, even those who participated last year. The comments that are coming in are already very positive. I know that we got a question about where we can get the slides. We did post Kyle's GitHub link for today's session, and the slides are available there. I will also share just a moment, unless Kyle is pulling it up himself, but I was going to share, let's see. The slides are also available at the URL I provided here. And just a reminder, as Kyle already mentioned, we will have another session next Friday and the Friday following. So please join us then. Please sign up for those, register, I believe at the same link. You'll also receive emails in the coming days, both with information on how to register, as well as a link to the video when it's posted. Please feel free to also contact us at ssdan-acs@umich.edu with any other questions or concerns. I think that's all I have from us. Thank you again for participating. Thank you to Kyle for just a great, phenomenal presentation. Always love to see, the new things that are coming out in the, in the tidy kind of census environment. So thank you so much. And we look forward to learning more next week.
All right. Thanks again, everyone.